The following video introduces the concept of imaginary numbers. Now, in the past, you've learned that you cannot take the square root of a negative number. You have the square root of -8. You learned in the past that that is not possible. That is not possible only with real numbers as the answer. But if we introduce the concept of imaginary numbers, we are now able to take the square root of negative values. So imaginary numbers, if you have any positive real number b, and you take the square root of -b squared, what you can do is split the negative into b squared, so it's b squared times -1 in different square roots. The square root of b squared is b, and the square root of -1 is I. And we use the letter I to represent the imaginary number. So what we need to remember here is that I, the imaginary number, is equal to the square root of -1. Now we're going to do one example mathematically. We're breaking it apart like we did here, and then I'm going to kind of introduce a little shortcut that I use to introduce imaginary numbers. So if we look at the first example, square root of -8, we can break it apart, the square root of 8 times the square root of -1. And remember the square root of 8, we can simplify this down. We have 8 breaks down into 4 times 2, which breaks down into 2 times 2. You have a pair of 2's, and you're left with the 1 inside. So square root of 8 simplifies into 2 square root of 2 times the square root of -1, just drops straight down. Well, the square root of -1 is I. And so you don't say 2 radical 2 I, you put the I between the 2 and the radical, so 2I radical 2. Really, like if you look at it, you see square root of 8 times square root of -1, which is, I square root of 8, and then you simplify square root of 8 to 2 radical 2. So we do have to remember simplifying radicals. Now, my little trick I use is that if you were to imagine this negative floating outside of the radical, and as it floats, it turns, it would become an I. So if I have, and I can show you the square root of, I have -16. To turn the negative into an I right away, imagine it coming out, coming out, coming out, and as it comes out, it rotates, and you see the letter I. So one quick way of dealing with, negative numbers inside of a radical is to pull it out right away and turn it to an I. And then you have just the positive square root, which is very easily simplified. Square root of 16 is 4. Just like how you deal with variables, you don't say, x4, you say 4x. You don't say I4, you say 4I. So it's the same idea. Imagine the negative sign coming out, rotating, it becomes an I. And so you have I square root of 9, which is 3I. So in my opinion, instead of breaking it apart into this every time, what you can do is just quickly take that negative out, imagine it rotating, turn it into an I, and then just simplify the radical as you've learned before. So let's look at a couple other examples. We have square root of -25. So I see I have the square root of negative, so I'm going to pull that negative out right away. And as I pull that negative out of the radical, I have to imagine it turning, and it becomes an I. So I have I square root of 25, and the square root of 25 is 5. So I have 5I. Now this one may be a little bit trickier. You have a square root of a fraction. Remember, a square root of a fraction means that you can break it apart. So you take the square root of the top, and you take the square root of the bottom. Now taking the square root of the bottom is pretty easy. Square root of 4 is 2. Now the square root of the top, I'm going to work with separately. You have the square root of 12. Remember, I would take that negative out right away, make it into an I, and then simplify the radical. Square root of 12 breaks into 4 times 3. 4 is not prime, so 2 times 2. You have a pair of 2's with a 3 remaining, so you get 2I square root of 3. And so really you have, for your fraction, 2I square root of 3, and the square root of 4 is 2. You have a 2 on top and a 2 on bottom, so those cancel. And you're left with I square root of 3. So what we've learned here is that when you're dealing with a fraction, you can break the radical, the square root, into both the numerator and the denominator, simplify separately, and then piece together. Let's look at the next one. You have negative 27 x cubed in the square root. Again, right away, I would just take that negative out and turn it into an I. So you have I square root of 27x cubed. And then what I would do is I'd work with everything separately. We would simplify the square root of 27, separate from simplifying x cubed. So 27 breaks into 9 times 3. 3 is prime, 9 is not, so we break it down to 3 times 3. You have a pair of 3's with 1 remaining inside. So the square root of 27 is 3 square root of 3. You do the same thing with x cubed. I mean, x cubed is x times x times x. You have one pair of x's with another one remaining inside. So x cubed in the square root becomes x radical x. Now we piece this all back together. On the outside, you have a 3, an x, and an I. And so you have 3xi square root. Inside, you have a 3 and an x. So 3x. And that is your final answer. Let's do it one more time with number 4. Again, I would pull apart the negative, turn it on the outside, and make it into an I. I'm going to grab this, and I'm going to move them away just to give us some extra room. And so we have here, take the negative out, I, right away, square root of 121 x to the 5th. Work with them separately. So really you have the square root of 121, and you have the square root of x to the 5th. Well, the square root of 121 is 11, so that's perfect. Now the x to the 5th is the tricky part. But we can realize what you're doing is when you're trying to simplify radicals, you're looking for pairs, you're looking for sets of 2. And so when I had x cubed in the square root, I had only one set of 2. Now the shortcut for this, whenever you're dealing with variables and exponents, is to divide by what the root is. Being a square root, that means you're going to divide the exponents by 2. And I'll explain what that means. So if we divide 5 by 2, it goes in there nicely 2 times. So you get x squared on the outside. And if you were to take x squared and 2, it means you have 4 total x's. You want 5, so you have 1 remaining inside. So on the outside, we have an I, we have an 11, and we have an x squared. So you have 11x squared I. And on the inside of the square root, you have just an x. And so my final answer is 11x squared I square root of x. So you divide the exponent by 2, the nice number goes on the outside, however many times it goes in there nicely, and the remainder goes on the inside for it. And so when you're dealing with imaginary numbers, you're dealing with negatives and square roots. We can't do it with real numbers. We have to look at the imaginary number I in order to do it. You can break it apart mathematically as we did in the first example in this video, or we can go through and pull the negative out right away, change it to an I, and deal with simplifying the positive square roots.